Table Part 1. We've previously looked at how to read the periodic table in terms of the information contained in the numbers, which tell you about the protons, neutrons, electrons, and the mass. If that's what you're looking for, that's not this video. Go and watch this video here about the atom. It covers it in that video. What I want to look at today is the periodic table itself. You'll have definitely seen this on the wall of your classroom or in your textbooks or online. It's a very cleverly designed document. Once you learn how to interpret it and tease all of its secrets out, it can tell you so much about the elements. Of course, the periodic table is a list of elements. There's 118 of them at the time of recording, and they're arranged in this way for a reason. They're not alphabetical or random. Their position on the periodic table tells you a lot about that particular element. First, some terminology. The vertical columns are called groups, and there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8, going left to right. Notice there's a large section in the middle which is not classed as being in a group. These are called the transition metals, and they're located between group 2 and group 3. All of the other columns are called groups, and they have a number. The horizontal rows are called periods. Now, period 1 contains only hydrogen and helium. Be very careful. A really common mistake students often make is forgetting about period 1 and starting to count the second period as period 1. It's not. The first period has only 2 elements in it, H and He, hydrogen and helium. So the periods are 1, 2, 3, 4, 5, 6, and 7. So to locate an element on the periodic table, we can give its group and period number. So the element in group 3, period 3, is aluminium. The element in group 2, period 4, is calcium. So what do the groups and the periods tell us? Well, the elements that are in the same group have the same number of valence electrons, outer shell electrons. All the elements in group 1, hydrogen, lithium, sodium, potassium, and so on, all have 1 outer shell electron. All the elements in group 2 have 2 valence electrons. All the elements in group 3 have 3 outer shell electrons, and so on. Notice again I skipped the transition elements there. We'll look at the transition elements next video. Elements in the same period or row also have something in common, which is that they have the same number of electron shells. Hydrogen and helium have 1, lithium, beryllium, boron, carbon, so on, have 2. The elements in period 3 have 3. If you're not sure what I mean by valence electrons or electron shells, you can watch this video where I explain those. So the group columns tell us how many valence electrons an element has, and the period rows tells us how many shells it has. Again, if we know nothing about an element, but we know its position in the periodic table, we know some information about its structure. So looking at an element at random, selenium, I know just from where it is that it's got 4 electron shells and there are 6 electrons in the outer shell. When we have this information, we can then use that to do all sorts of things like see how many bonds it can make, its properties, and so on. Speaking about properties, let's look at some properties. The periodic table is arranged very cleverly so that there are a series of patterns or trends in the elements as you move around the table. We'll take a look at the ones that you need to know about for IGCSE. Firstly, a very big trend in the periodic table, going from left to right across the table, the elements get less metallic. What this really means is the metals are on the left, the non-metals are on the right. If in an exam you're asked to describe the trend in metallic character, you would say it decreases going left to right, or the elements get less metallic on the right of the periodic table. Another trend in properties is found in the groups, which are the columns, remember. I'm just going to go over the properties you need to know, but there's some great videos that will actually show you and demonstrate you the properties, especially in the reactivity of group 1, group 7. I'm not set up to do that here, so if you've never had a chance to see that yourself, go find one of those videos. I'm just going to go over the descriptions that you need for the exams. Anyway, if we look at group 1, lithium, sodium, potassium, so on, they have some things in common. Well, we already know they've all got one valence electron, but something else we already know, because they're on the left, they're all metals. So they have the properties of metals. They're malleable, they conduct electricity, they're ductile, they're shiny. Something that they all have in common as well, just in group 1, is that they are soft, which is different to normal metals. They're very soft, they can be cut with a knife. Just a normal knife that you'd use to put butter on your bread. They're all also very reactive, which again, compared to other metals, normal metals, they're much, much more reactive. This is best seen with their reaction with water, where they produce hydrogen gas, a very exothermic reaction, produces a lot of energy. They produce hydrogen gas, and they also produce an alkaline solution. They produce a hydroxide. If it's lithium hydroxide. If it's sodium hydroxide, and so on. This gives this group, group 1, its name. The name of the group 1 elements are the alkali metals. So that's what they all have in common, but there's also trends within the group. As you go down group 1, their melting point decreases. That means they melt at a lower temperature. Also, their reactivity increases. They get more reactive as you go down the group. So potassium is more reactive than sodium, which is more reactive than lithium, and you can use this to predict properties of elements that you haven't seen. For example, a very common exam question will ask you to predict the properties of cesium or rubidium. And you would say, well, it follows the trend. It's more reactive than potassium. It's got a lower melting point, and so on. So that's the overall trends in the periodic table in terms of metal and the shells and the electrons, and also the trends in group 1. This is part 1 of a 2-part video, so I will stop there for today. Come back next time to see some trends in group 7 and group 8, and also in the transition metals. Thanks for watching.